In this lesson, we're going to get an introduction to object-oriented programming. Now, what exactly is object-oriented programming? To understand the concept of object-oriented programming, you have to understand the concept of an object. Now, if you look at the world around us, everything is an object. We got smaller objects that fit together to form bigger objects. A good example would be a car engine. When we're looking at a car engine, the car engine itself is an object, but it is made up of countless tiny little objects. And these objects put together form the car engine. They put and assemble together, they form a fully functional car engine. Now the engine itself is an object, and it is a part of yet another bigger object, which is the vehicle itself. Now, computer programmers decided, let's make a system where our computer programs will mimic the real world in terms of how they are created. Rather than creating one single program that's made up of countless lines of code, let's take our program and break it up into smaller objects, just as in the car engine. And each of these tiny objects will serve a specific purpose. It will do its own little function, and it will, throughout the lifetime of that object, it will conduct its whatever it is specialized to do. It will continue to do that. Smaller objects put together will form bigger objects. Bigger objects will form components, and components will form sections of applications, and applications in turn, just like a car, will be fully functional objects in themselves that people can use. Now, that is one of the biggest advantages of object-oriented programming. Our programs are created in tiny little units put together to form components, and the components put together form entire systems which operate. Now, that's only one advantage of object-oriented programming, in that it makes things easier. But object-oriented programming also provides another benefit, and that is of inheritance. Now, if we take a typical video game, like Plants vs. Zombies, for example, we know that each item on our screen is an object. The plant is an object, the zombie is an object, the sun is an object, the lawnmowers are objects. Now, these objects all put together work in a harmonious way to make the experience that is the game. Now, let's take an individual item from the Plants vs. Zombie game. Let's take a single zombie. Now, this is the base zombie, the most basic zombie that you get. Now, besides this zombie, you get other types of zombies. You get the zombie, the conehead zombie, the football player zombie, and the newspaper zombie. Now, each of these is in its own right a zombie, but if you look at them carefully, they are actually all identical. They are all identical to the base zombie, and they just have add-ons. So what are the add-ons? Maybe a little bit of costume, a little more strength, and a little more speed. Now, object-oriented programming will allow us to create just the basic object, which is the base zombie. And that base zombie will have X lines of code, a certain number of lines of code that we will need to create it. Let's say it takes 100 lines of code to create this zombie. Now, when we're creating the conehead zombie, we know that it's the identical zombie, but with slight differences: the cone on his head, and added speed, and probably added strength. Now, instead of writing yet another 100 lines of code, all we need to do with an object-oriented programming system through inheritance is to inherit all the characteristics of the original zombie, the 100 lines that belong to the original zombie, and then add on a couple more lines to specialize it to meet the needs of the new zombie. It's the same with the football zombie as well as the newspaper zombie. They are all identical with slight differences. So in a sense, we inherit the common characteristics and then we specialize them.